Whenever you have thought a question long enough, grinded it for many minutes, and still not getting out to approach, what is the first thing you do? Look out at lead code hints, maybe, to get an idea of that question. Sometimes it also happens that you have an approach in mind. Okay, this might be the approach, but you are quite not sure that if your approach is the right approach, optimal approach or not. And that's when you go again to look hints to check if your approach is the right one or not. So maybe that's not the right approach always. Maybe your approach was actually right and lead code confused you. Lead code hints were they're meant to confuse you in the wrong direction. So today I will show you that why that is not the right idea to always follow hints blindly and not think of your approach as superior. So here we have this question: earliest finish time for land and water rights too. It was question of the day on third of April, 3rd of June. Sorry. So the question says you are given two categories of theme park attractions: land rides and water rides, and then you're giving land ride start time and the land duration, and then you're giving water ride start time and water ride duration. So a tourist must experience exactly one ride from each category in either order. A ride may be started at the opening time or any later moment. If a ride is started at time t, it finishes at time t plus duration. So you have to choose, you have to do at least one ride from both of them. And you can do either one first. You can either do land rides first or you can either do water rides first. And immediately after finishing one ride, the tourist may board the another if it is already open, or wait until it opens. So we have to return the earliest possible time at which tourists can finish both rides. Mind it, you don't have to do all the rides in land and water. You just have to do at least one ride from land and one ride from water, one slide from water. So that is the question. This was a bit confusing part there. This is rated as lead code medium. Let's have a look at the constants. Constants are 5 into 10 to the power 4. So if you think of anything on the line of big of n square, so that will fail. You have to come up with a linear solution. So I will show you the examples, like what exactly the examples are and what exactly the approach is. But before that, I want to show you the hint. What the hints are. Hint one: sort each ride list by opening time and build a prefix minimum of ride durations and a suffix minimum of binary ride finish time. Damn. Then do finish one is equals to start one plus duration one. Try both sides, bro. Then binary search. Binary search the second list sorted by start to split rides into. Bro, I don't even want to read this, bro. Leave it. Just leave it. And the hint for is for each pairing, take the smaller finish and track the overtime. So how does it seem? Prefix some binary search. Oh my god. Does it look like a medium? No. Actually, it's an easy. The approach just confuses you. Let me show you. Suppose this is an example. Our water ride starts are 2, 8, 3, 4, 1, 2, 4, and the duration for each ride is 1, 2, 4, 3. So if you take a ride, how long would it take you to finish? For a water ride, it would take you here 3 to finish. It would take you 3 seconds to finish. Just a second. Yeah. For a route, yeah, 3. For the second, it might take you 8 plus 2, 10. For the third, it might take you 7. And for the fourth one, it took you 7. Similarly, for the landslides, it will take you 5 seconds for the first slide, 5 seconds for the second, 13 seconds for the this one, and 4 seconds for the this one. Okay. So what if I tell you the optimal approach is always that you see that which slide is taking you the least time. Like in water ride duration, this 3 second is taking you least time. So you pick it up, you do the 3 second slide, and then you go into the landslide duration, and you see which of these can be done have start time greater than 3. You see this has a start time immediately greater than 3, and 3 plus 2 is equal to 5. That is the minimum. Now you might say 1 plus 3 4 is minimum, but I will only see the landslide that starts after this. So I will just see that 5 here is maximum. I like 3 plus 2 1 5, and I just do this ride. It takes me 2 seconds more, and boom, in 5 seconds I have done one ride from this one also and one ride from this one also. Okay. And the second thing you might have to check is that which ride takes you the least time on this side of the map. So here, if you first this one, this 4 second takes you the least time, 1 plus 3 4. So I take this, and then here I will pick up a slide which starts after 4 second. I cannot choose this 2 second one. I cannot choose this 3 second one. I can choose this 4 second one, 4 plus 3 7, and I will choose this. So it will take me 3 seconds from here more, and that will give me 7. So I get that this is the optimal approach, and this is my answer. Yeah, that's the solution. No binary search, no sorting, no prefix sum. The lead code hints were just there intimidating you, making a fool out of you. That's what those hints do normally. So don't follow them blindly always. Chalo, let's start to coding our solution then. So first of all, like I know that I have to do the same thing twice. I have to first check for land. I find the slide which takes the least time in land start time. Then I will take that as my base case as I explained you, and I will find the optimal slide here in the water duration. And then I will do the same thing otherwise also. So why to write the same code two times when I can do that once? So I will just copy this and create a function so that I am able to do this more optimally in solve. And I will keep a variable name easy for me because I don't want to type these long names again and again. So I will just keep it v1, v2, d1, d2. Yeah, that's pretty much it. These brackets are unneeded, two brackets. I don't know why. So yeah. So now let me declare the sizes of these. So n will be the size of v1 vector, and m will be the size of v2 vector, and d1 will have the same size as v1, and d2 will have the same size as v2, because they store how long the ith slide lasts, so they will have the same size. And then I will declare variables which will declare size for which will declare the value for the minimum slide. So I am declaring that as mini. Whenever you are looking for a maximum minimum in a whenever you are trying to find a minimum in a vector, initialize that value with maximum possible, because minimum will only reduce it. And whenever you're trying to find the maximum in a vector, initialize your container with the minimum, so because it will only increase. And my ans I will also initialize here only with int max. Come on, let's jump into the loop now. For int I is equal to 0, I less than n, I plus plus, I just find that of all the solutions, which one takes me, of all the slides, which one takes me the minimum time. So minimum of mini and v1I plus d1I. This will give me which slides takes the minimum time. Then as soon as I get that, I will quickly run a second loop, and that will run till m. And in that loop I will try to store my answer. I will try to find that after the user has completed this v1 slide first, the slide which takes the least time from v1, then which slide would be most optimal for it from v2. So answer will be equal to minimum of answer, and here I will do maximum of mini and v2I by that. See, v2I is the start time here. Suppose this is v2I. So v2I is the start time of the slide that I am doing, and this the value that I get is the total time. This mini is the total time that has taken to complete the slide from v1. So suppose it is 3. So after that, I can only do slides which are greater than 3. So if I'm doing 4, I'm starting at time 4. So that's a maximum of 3 and 4. It will be 4. But if I'm doing it 1, I can't do it. I will obviously do it after I have passed 3. So in that case, I'm doing the slide at 3 seconds, and that's why 3 plus 3, it will be 6. So that's the reason, maximum of this plus d2I. If you just write it on paper and try to understand, you will be easily be able to understand it. So yeah, I hope that makes sense to you. Return answer, and then I will just make a call to that loop two times. Int answer one will is equal to solve. Just let me copy this. I won't be okay, or maybe we can write it. It won't take that much time. Land start time and land duration. Now I will copy. That's easier for me. Land duration, and I need to remove this vector in because I'm making the function call here. I'm not initializing the function. Yeah, pretty much done. And then I will also declare int answer 2, and that will have the same thing, just the places of v1 and v2 will be reversed here. So this just will come at the starting now. Cool, pretty much done. And then I will just need to return the answer. That will be minimum of answer 1, answer 2. That's it. That's a solution. Simple. Let's run it and see how is it, if I have done any simple basic mistake or not. Okay, it's working, and I've submitted it, and it's passing all the test cases. Boom, optimal solution. So our solution is basically solving it in big O of n plus m. Like this loop is running from big O of n for finding the minimum, and then this loop for finding the answer is running for big O of m. So it's big O of n plus m that is running two times. I'm making two calls. So big O of 2 times n plus m, a simple solution. And mind you, the hint is like that people try what not. Like I have seen solutions, people trying binary search, sorting, and a prefix sum. Oh my god, just leave it, bro. So that's basically how these questions often fool you. So it like when I was approaching this question first, I thought of this solution. I was trying to go ahead with it, but then I got saw the hints and I was like, boom, bro, I might be doing it wrong. Maybe my approach would be wrong if hints are like something that crazy. But still, I went ahead with my approach. I executed it, and yeah, it worked. So I that time I realized that how these lead code hints many a times fool you. So yeah, that was it in this video. I hope you enjoyed it. If you have anything, you can put it up in the comment. I will be happy to help you. And yeah, that's it. Thank you. Like and subscribe.